Okay, so now we're going to take a look at another question. This comes from the HSC, this is from the HSC Advanced Maths 2023 paper. HSC Advanced 2023. This is question 30. So we are told to find the coordinates of the stationary points of the function between 0 and 2 pi. You do not need to check the nature of the stationary points. Okay, that's important because it's going to be difficult to do, presumably. So it's going to take too much time, so we won't do that. So stationary points, that's first derivative. So we're told the function of x is equal to e to the minus x times sine of x. If we need the derivative, this is going to be a product rule. So this is u, this is v. So we've got u is e to the minus x. This means u prime is minus e to the minus x. E to the x stays the same, but there's a minus 1 from the power. V is sine of x, and the derivative of sine of x is, of course, cosine of x. So these are easy derivatives. This means our total derivative, f prime of x, is going to be equal to u prime v minus uv prime, which will be minus e to the minus x times sine of x, plus e to the minus x times cosine of x. Minus x times cosine of x. And we can factorize this. So we can take e to the x out the front. We've got e to the minus x out the front, and then we've got minus sine plus cosine. So we'll write this as cosine x minus sine x. Now for stat points, this is going to be equal to 0. So this is our condition. This has to be equal to 0. We'll use a little exclamation point to demonstrate that this is a condition imposed on the question. Because of the way we factored this, either this is equal to 0 or this is equal to 0, right? For the product to be 0. But there's a problem here. E to the minus x cannot be equal to 0 because it is a negative tail exponential. Right? It sits completely above the x-axis. So e to the x or e to the minus x are never equal to 0. And that means cosine x minus sine x must be equal to 0. So we find that the stationary points have the quality that cosine of x is equal to sine of x. Because cosine x minus sine x equals 0, add sine x to both sides, you get sine x equals cosine x. So the stationary points for this function occur at the points where cosine is equal to sine. Now, for some students, they'll immediately know where cosine is equal to sine. For most people, they won't. So we're going to draw our cosine functions and sine functions. So this is sine. It's like this. Cosine is sort of very similar. Goes down, comes up like this. So now we have to find the 2 points or multiple points where they intersect between 0 and 2 pi. This is 0, this is 2 pi. Well, because of the symmetry, they have a point right here, which is halfway between 0 and pi on 2. So this is going to be pi on 4. And then there's also some symmetry over here that we can use. They have to be pi on 4 away from pi. So this point will be 5 pi on 4. So this means one of the points where cosine x is sine x, which we'll call S1, is pi on 4. And the other point, which we'll call S2, is 5 pi on 4. Now, these are the x coordinates, obviously. So this is x1 and this is x2. To find the coordinates of the stationary point, we also need the y values. So for x1, where the value is pi on 4, we can plug that in. And we get y1 is equal to e to the minus pi on 4 times sine of pi on 4. And then the second one, we get y2 is equal to e to the minus 5 pi on 4 times sine of 5 pi on 4. 5 pi on 4. Once you're at this point, you can pretty much just numerically simplify these with a calculator or with a computer. So we've got our x values, we've got our y values. These are the coordinates of the stationary points though. Right? And so this is actually all we need in order to do the first part of this question. So let's do a little breakdown of the marking. I'll do the second part in a separate video. We get 3 marks for this question. So you're pretty much going to get 1 mark for taking a derivative. So if you're able to take a derivative, able to use the product rule correctly, get a derivative function, something like that, that'll be 1 mark. If you're able to use that derivative to start to find the information needed to get the stationary points, that's going to be a 2nd mark. And then if you're able to correctly find and evaluate both of the stationary points, the x coordinates and the y coordinates, that's going to be the 3rd mark. So this is how we do question 30A from the 2023 paper.